Hello, everyone, and welcome. How are you doing on this lovely pandemic day? I'm doing great. We're in the middle of a pandemic. It's time to learn. It's time to check things out. It's time to have a good time. At the beginning of this pandemic, I had a six pack. I was nice and lean. I was I was beautiful. Some said I looked like a young Brad Pitt, and I was like, "Thanks, Mom. Yeah, I do look good, don't I?" But, besides that, we're here and we're gonna have a good time because I have one of my good friends with me. So if you're new to 3D and photogrammetry and all these cool things that we're about to talk about today, or you're like pretty advanced far down the road, you're gonna learn something today. And so, without further ado, let me introduce the man with the street as a middle name, but a saint in my eyes, Josh St. John. What's up, man?
Thanks, Tito. I always love your introductions.
I just want to have a good time with it, and I want to introduce you, and I want people to know that, I have much love and respect for you. And we pretty much do these talks, you and I hanging out and you impressing me every couple weeks. So it's kind of fun that we get to do it now for an audience and, chat about cool things.
Yeah, well, when they asked if I knew a moderator had somebody to pull in, I immediately thought of you. You're a creator too, and we're here to talk today about like equipping creators and making sure they have the tools that they need and building tools for creators. And I love the story of how we started working together. I was like, they wanted to do a podcast for the brand Z by HP, which is where I work. And the podcast, it seemed like it was going to be a lot of work. So they needed somebody full time and they wanted me to do it. And I'm like, no, you need a guy like, I don't know, like a Tito Hamzi from TechCrunch or something like that. So I went over on LinkedIn and I looked Tito Hamzi for TechCrunch and I see you work at HP. So I immediately switched over to our like internal instant messaging tool and found you, which wasn't easy because your name was listed as something different. I was like, do you work at HP? And you're like, yeah, I do now. And I'm like, oh man. So you came and you helped us with the podcast. That was really, I had a lot of fun with that podcast. You?
Yeah, no, I had a great time. What was funny about that is when I remember you emailing me and I got the message on LinkedIn and it was like, hey, are you interested? And then you were like, wait, you work at HP? And then the conversation transferred to internal chat, which I thought was hilarious. But yeah, it's so serendipitous, so organic, so natural how that all happened, and it's always a fun story to look back on. But I have another.
No, plug it though. Let's give it a proper plug. Everybody should on wherever you get your podcast, Spotify, Apple Music, whatever. Check out Right Brainers with Tito Hamzi. It's really I think there's 6 episodes. They're all really entertaining.
Yeah, really appreciate it. hp.com/rightbrainers. Check it out. Plug. But what I was gonna say is I feel like one of the reasons you had me moderate the session with you is because every time we talk about things, I'm like, what? That's so cool. You're doing what? So like the whole time you're just impressing me. I love it.
You're a creator too. So you're using the ZBook 17 I sent you, right?
Yeah. I use it all the time. It's my main workstation right now.
Even before I came to HP, I used the ZBook 17 for 10 years. I dragged them around the world with me. It's like a mobile desktop, basically. It's very powerful. So yeah,
That's awesome. Let's talk about that journey then. Let's get right into it. So how did you tell me about your journey, how you got to where you're at now?
Yeah, I mean, it's a long serendipitous route, but I mean, kind of I got really lucky. I was exposed to digital manufacturing really early in my life. Like I think I was like 14 when I first got access to a CNC machine in my tech class. Shout out to Mr. Slater, who kind of helped me that. And in that same tech class, we also had, in addition to the CNC and numerical router, we had early 3D modeling. It was 3D Studio 4.0. It's become 3D Studio Max now, but this is before Autodesk acquired the company. It was DOS. It had a parallel port dongle. And I just remember like drawing a cube on the screen and rotating it and just being like, wow, this is cool. So yeah, I got started early. We had a video toaster, an Amiga video toaster where you could do like video editing, et cetera. So really lucky in that way to be able to, just have that access. And to me, it just reinforces like how important public education is in this time of the pandemic, when we're all having to take responsibility for our kids' education in ways. There's so many resources today. Those tools, maybe not the CNC router, but those tools are all available on the interwebs. So for parents, the key is just curiosity. And that's what was kind of sparked in me very early. And I just always try to chase the things that I'm curious about. And so far, so good.
That's awesome. But, Josh, you said you got started early in digital manufacturing. What does that encompass?
Yeah, that's a really good question. So I'll talk about it, like what it encompassed back then. What it encompassed back then is there was these big machines, and I already liked power tools as a young teen, but there was these power tools, and they were attached to computers, and so do you remember those games at restaurants and stuff with the pegs and the boards where you would like skip over each other, and if you hopped over the peg, one would be removed? It was like just like an early board game kind of thing.
No, I don't remember that one.
Anyway, so you could take pieces of wood or pieces of plastic. And at that time, I actually had to punch locations into a panel of like, move the tool here. And then I'd write these programs. And once I wrote the program, I could just cut plastic, or I could cut metal and drill holes in it, et cetera. So digital manufacturing was being able to operate those tools, not by hand, being able to write a program. It was G code. I didn't know it was G code when I was learning it, but write a program and then execute it many, many times. So you put a little more work on the planning, and then it executes. And today, digital manufacturing, extends across every supply chain. It's just everything's digitizing, and with additive manufacturing and 3D printing, there's all these new possibilities of ways to express shapes, because with those early tools, I could only make it go in the direction the tool could go, and I could only cut the materials that the tool was rated for. So the last 25 years or 30 years since then has been, really a digital manufacturing renaissance.
So then what were the steps for you in your career, in your life, going from that point to this point now?
It comes down to that curiosity. So we have this idea at Z by HP of the studio of the future, and the studio of the future is it's really just like a work in progress. So Pierre, if you can cut over to the slides, we have a slide of this ecosystem that we have at. Let's cue the sound on this one. Play the Z by HP video.
Into 3D with the computing power of Z. It's one breakthrough that unlocks 1,000 more. This is not a tree. It's the next era of your creativity. Z by HP.
But the narrative of that video is about a journey from 2D to 3D. And it's about how an artist can jump and make these, like back to the podcast, powering your breakthrough. So, the ZBook Studio, there's never been before a laptop that thin and light with color accurate display that can support up to a Quadro 5000. It's a pretty revolutionary machine in terms of, like, if you compare it to the ZBook 17 or to some of our competitors, it really makes no compromises on the quality. And I thought we could highlight that video because it really gets us to the point of, how we're equipping creators and how we're making tools for them. So I have one of those sitting under my desk here, and once we start traveling again, it'll probably become my main machine. But yeah, that's just an amazing video that was made by Framestore, which is a Z by HP customer that does video and motion graphics, VFX work. They're Oscar award winning, And just wanted to kind of start off with a little bit of what we make.
Yeah, no, it's pretty sweet. It looks beautiful. The images.
Yeah, so the studio of the future is this idea of at HP we have some assets that we don't have anywhere else. We have a lot of capture capabilities, so being able to take the analog world and digitize it, and then we have all of our compute capabilities where no matter who you are, whatever industry you're in, architecture, engineering, construction, designing and building the places we occupy, product development and manufacturing, designing and manufacturing things that are made in factories, and to media and entertainment, the games and movies we enjoy. We have, all of these different capabilities. And on the experience side, this is the one that gets really interesting to me. Experience, you can think about VR and or you can think about, color accurate screens. But experience is also like the physical things that we use. So being able to 3D print something, or use one of our large format printers to print beautiful photographs onto different substrates, our indigo presses, our web presses. We have all of this like industrial capability to be able to connect the capture to the experience. And removing that friction is kind of the goal.
Yeah. Hey, just really quickly, I want to just put it out there that if during this interview you have any questions or anything, please feel free to submit them, and we can ask them to Josh also. And it makes my job easier too. So. Yeah,
I like that. If there's audience members that want to ask a specific question about some of the things we're showing, don't wait till the end. Dive in, because it'll be curious. Cool. So I think advancing, we'll jump right into the kind of, you asked a little bit about where I came from and how it started. Yeah. My first professional roles were in design and manufacturing for jewelry. Mm-hmm. So
were you, when you got started in jewelry, were you all blinged out with like necklaces and stuff all around your neck and chains and earrings and rings?
No, not at all. It was the total opposite. I was always very interested in like minerals and going mining, and I always had like a rock hammer and was like collecting rocks. So it actually started from just an interest in the materials, and the best story is the first time I ever saw a 3D printer. I told you I had that previous experience in high school doing 3D modeling, and through a strange series of events that took me through like visiting India and like the whole backpacker thing, and then down into Brazil. I was in a jewelry shop actually in New York City on 47th Street, and I saw a guy using CAD, and I said, "Oh, hey, I know how to do that." And I'm like, "Oh, yeah." And he's like, "Oh, cool, yeah." So then I 3D print the parts in wax, and then we cast them into metal. And I'm like, "Oh, that's cool. So you cut it out of a piece of wax?" And he said, No, we 3D print it. He didn't say 3D printing at the time. He called it rapid prototyping. And this is probably 2004, I think. Mm-hmm. And his machine was sitting there, and he kind of described to me the process of it laying down the waxes, and he showed me, and I was just blown away. And I said, "Wow, this is unbelievable." So you just draw it in the computer and you print it. You don't have to like program a code or be limited by the shape. You can just print it. And he said, "Yeah." And so I kind of went through that, and over the years I worked for about 10 years in jewelry manufacturing, just doing design and production of jewelry for a lot of different brands and a lot of different companies. This is just some of my own work that I'm showing off. This stuff is all, again, this all goes back to like 2005, 2006. So it looks a little dated in the rendering. This is a fun one, and I'm gonna try something different here where I actually have a live camera. I think you guys should be able to see my hands. Yeah, this way we can, like look at some parts. So, this was kind of like an object art object that a friend of mine wanted made for his temple. So he kind of gave me some ideas and a lot of freedom to design it. And I really loved like geometric patterns and patterning. So I just went a little bit crazy. And this was printed in a wax and then cast in a brass. And this is not something I could carve by hand, for instance.
Yeah.
And I think we made about 5 or 10,000 of these. I can't remember exactly, but we made a whole mess of them. And being able to make one master model, and then from there we would cast it. This was the workflow that I was most familiar with 3D printing for like the first 10 years of my career. It was really starting in CAD using a pretty high powered computer. My first CAD program that I used was Rhino. I still use it to this day, and I love Rhino. All the plugins for it make it so amazing. But then, then it would be made into a physical mold that you could make more of.
So something like that, how long would it take to create that? And what is that material?
Yeah, so I don't remember how long it took me on the 3D modeling. Something like this now would probably take me, the better part of a day, maybe 2 days. It looks really complicated, but there's a lot of repeating kind of patterns in it. So you get some benefit there. And then the material it's a brass now, but it was first made in a wax and then turned into brass. But yeah, maybe today I could do something like this in a day and a half.
That's very cool.
Yeah, so the jewelry industry was super interesting. There were a lot of machines introduced at that time. This is right around the time that the kind of maker movement was starting too. I think you remember that well. The maker fairs were popping up, and MakerBot was over in Brooklyn, and I was living in New York City. So 3D printing was kind of coming out of just being used in specific industries and kind of entering into the mainstream consciousness in terms of like the welcome to the future. This is a replicator kind of thing. And at that same time, I'm going to flip back over to my slides. I wanted to push my design further. So I got into, I was limited by my artistic skill. So there were a lot of dental scanners kind of coming into the jewelry industry, like for scanning crowns of your teeth and things like that. So I got my hand on a dental scanner, and this is a project I worked on with a buddy named Harry Hamel. If you're out there, Harry, saying hi. And this one was pretty cool because on the left, there's the physical model, and on the right, we scanned it, and then Harry actually cleaned it and redetailed it, and then we turned it into a new master model. I'm gonna flip back over to my hand camera, show you what those parts look like. I remember I found this little ring in like a thrift store, and I think I paid like $8 for it or something. But you see, it was pretty old and beat up. So yeah, then we 3D scanned it using these dental scanners, and this was the reproduction.
Oh, very cool. And the detail is just as good as the original?
I think the detail's better. The scan, we lost some of the detail, but then Harry's really artistic, so he went in and kind of reinforced a lot of that detail. And then this is called a sprue, so we put the sprue on it and made a model, made a mold of it. So this becomes the master model, and then you can make these rings. But the thing that was really amazing to me at that time was that I could capture a physical thing, turn it digital, modify it, and then bring it back into the real world in any material that I wanted. And that felt like a superpower. And I was like, not only did I think digital manufacturing was cool at that time, I became obsessed with 3D scanning in all of its forms. So I'm going to pop back over to our slideshow here. You can really see in the details, like that thing's pretty small. I was able to catch the teeth, etc. but there were some occlusions and stuff. So we went back in and cleaned it up into the master model. So this is kind of when my obsession with scanning people came in. So Tito, do you remember the Microsoft Connect for Xbox?
Yeah. I remember a lot of people were using it for like robotics projects too. They were connecting it to give it like computer vision of like traveling through rooms.
Yeah, so the company that originally made the sensor in there was called PrimeSense. They actually were acquired by Apple way back then. But PrimeSense made that first camera, and it was funny because they made the Xbox camera, and then they made Connect for Windows, and there was this open natural interfaces was this thing that kind of grew out of there, and it was all of that stuff you saw where people were like controlling digital avatars and like 3D scanning in desk chairs. And I mean, we did one really cool project where we made a belt and we put little motors on it, and the idea was for like blind people or vision impaired people to be able to, the motors on the belt would vibrate based on where the sensor would see the people. So it was just a really rich time. This is 2013 probably, for scanning. And I personally scanned between 2012 and 2016 with a Connect-like device. I personally scanned like 3,500 people.
Yeah. That's amazing. Wait, and so you have all that information?
Yeah, I have all of the scans of the people.
How long did that take?
I mean, each scan took a couple of minutes. Each scan took a couple of minutes. I mean, I scanned some crazy people. I scanned Penny Pritzker, the Secretary of Commerce. I scanned Senator Dodd from Connecticut. I scanned Ray Kurzweil, Peter Diamandis, the Charlie from It's Always Sunny in Philadelphia.
No way. That's awesome.
Yeah. So I have this like huge collection of scans. I'll actually switch over to my hand scan now. I can show you a couple of them, but yeah, I got like, I would also like take the scans and like make little like plinths, these little bases that people go on. So this is Ray Kurzweil. It's like the Singularity guy. He really liked this. And, so I put his autograph on it, and then
that's awesome.
I print these things like 20, 25 at a time and send them to his house. And I think he gave them away to friends. Around this time, I relocated to Los Angeles, and I was working at the studio, and they made toys. So here's like a little Han Solo figurine, and this is actually my younger head, kind of resculpted to fit onto Han Solo, snap in there. But yeah, I was scanning everything. Switch back over to the slides. And I think that's, kind of brings us to like how I got to HP. So it was this kind of like, I went from jewelry industry just into 3D printing, got really into 3D scanning, and ended up joining HP in the immersive team. And this is 3D scans of the team that I think I took these scans when I first joined the group. And these were full body scans that I did of the team when we joined.
How are you handling full body scans? Is that also with just like a regular camera, or is that a special device to be able to handle such big objects?
Well, for these particular scans, it was like it was like having let's see, 2, 3, probably 12 or 15 Connects like devices. It wasn't Connect at the time. It was a little different device, and they were all pointed inside of almost like a photo booth, and you'd walk in and it would just go zzz, and you would scan. It would scan your complete body and merge it and fuse it. But I've also built a lot of photogrammetry systems. You mentioned it on the front side. So taking more of like a digital SLR, an expensive camera, and using that to build photo rigs, and it's hybrids between the two where you're using depth cameras plus cameras. The key is you want good geometry and you want good color data. Like, and depending on what you're going to do, it really changes what type of technology you'd want to use.
Yeah.
So if you want to 3D print something and manufacturing something, chances are you're really concerned with geometry. Like, you want that good geometry. If you're going to do renderings of something, you really need to have that good color data. And, you know, I feel like I've lived my whole, like the whole career between like CAD and CG and additive computer graphics, and CAD and CG are kind of like a hybrid that you have the opportunity to work with additive manufacturing.
Yeah. That's awesome. So then what did you start working on after you joined the team and you scanned all your buddies?
Yeah, so I mean, I think Pierre, if you can play video number 2, I think people might remember this product. I joined Immersive Computing right before the launch of the Sprout G2, and the thing that I liked about the Sprout G2 was it had a projector, it had a camera, it had a depth sensor. So we developed a new type of scanning, which is pretty common now, where you would capture the geometry kind of roughly, like so, and see how my fingers would actually like move away, and you'd be rotating the object underneath the sensor. But then you would take the really high quality 14 megapixel 2D images on top of it to get that really good color texture.
Yeah.
And this just felt like intuitive to me, like 3D. There was something, not necessarily the device itself, but about the style of scanning. It seemed that there was, something really intuitive. Again, there's my mineral collection. But just being able to take that like kind of low quality geometry and map those really high quality images on top was interesting. But you'll notice, see how there's like the hot spots, like the reflections?
Yeah.
Those were baked in, and that was problem. So like, if you want to use this in a video game or something like that, you'd actually have to go through and manually repaint that. So that was one thing I was concerned with while working on that project. But yeah, so I came into Immersive to run product management. And another product that they already had on their roadmap, if we switch over to, oh yeah, we got it here, was the idea of taking the camera hub out and attaching it to the back of any monitor just to make it more approachable. So this was an idea they had on. And actually, when I switched to my hands, that's what I'm using, the Z3D camera. So Pierre, if you just go ahead and pull up video number 3. So this was the launch video of the Z3D camera, and I think the funny thing about this video is we shot it up in Toronto. Do those hands look familiar?
They're looking very pretty. Are those your hands?
Those are my hands, and in fact, because it was like a union kind of Directors Guild shoot, I had to join the Actors Guild of Canada in order to participate in this shoot. And the reason why I had to participate was the device was so early, nothing really worked.
Yeah.
So we had to, I had to operate the equipment. But this is where we started thinking about, okay, if we can take the scans and add PBR, which is physically based rendering, and I'll get more into PBR in a second, that we could really enhance the visual quality of these scans and be able to use it for visualization use cases. So CG, game engines, that type of thing. And there's the Hurley Bear was the name of it. So that was the camera. Today, I don't really use the 3D aspect of it very much, but I do use the 2D hands part of it all the time. The thing I wanted to show here we are. We're getting to So in order to scan to do that video shoot, the guy there on the left devised this torture device. So it was a motorcycle helmet. There were some 3D printing components there, and it was really top heavy.
Yeah, it's like counterweighted and everything.
It was awful. It weighed so much, and there were like 14-hour days on set. And because of the way I had to shoot it, like I needed to stand like with my arms way back from the table to be able to shoot it. So, but I do love this picture because it's like a guy making tools for, making things. And so that I really appreciated his effort, but I needed, some like chiropractic work after that was all done. But the important point that it brings us to is really around this idea of digital materials.
Yeah.
So Tito, you're a creator. Do you know some things about rendering and
I know it takes forever to render anything. It takes a long. It's a tedious project to render anything out that I'm making.
You should try rendering on that new ZBook 17.
Actually, I did notice it does go faster on it. But anyway, back to your rendering.
Well, no, there's a technique that came out for rendering called PBR. For people from the States, we have a horrible beer here called Pabst Blue Ribbon that's also referred to as PBR, but this is the other PBR, physically based rendering. And if you look on the left-hand side, I have a base color, I have a normal map, I have a displacement map, I have a roughness map, and I have an opacity map. Mm-hmm. And these maps are tileable. So if I put them end to end, they make an infinite pattern.
Yep.
So you don't see the seams. Base color is pretty self-explanatory. It's got all the color, but like in that scan I showed you, all of the hot spots are removed.
Wow.
So you get that really clean color, so you can put the lighting in afterwards. The normal map, which is the direction the shadow bounces off of each pixel. Displacement is the geometry. Roughness is how shiny it is, and opacity is how see-through it is. So on the right-hand side, if you look, this is my geometry when it's all white. It's like, I think there's a little lag maybe, but when it's all white, it's geometry. Then I add the color, then I add the normal, then I add the roughness, and then I add the displacement. And with a low quality geometry, I can bring all of this detail out of the mesh. So that kind of brings us back to the Hurley Bear. So I'm going to switch over to my cameras, my hand cams for a minute. And one of the things when I joined HP, I was really excited about. I came from 3D printing, and I was really excited to get to use the MJF technology at that time. And I'd done a couple of projects, but one of them I called another sculptor buddy. This guy's name's Peter Kelly Studios out of New York. And we wanted like a hero for that video shoot. Mm-hmm. So he sculpted out this bear, and I was absolutely blown away by the qualities of textures that I could get out of MJF. I mean, there's no other machine that could create this type of texture in a nylon end use product like this. So that kind of got my brain thinking about a lot of different ways that we could kind of hack the PBR workflow and apply it to more of a digital manufacturing workflow. Mm-hmm. So to do something like that, this displacement map would be the key map that I would use. And just getting a little bit more technical, kind of showing you the differences between the scanning technology and the way the textures work. Up on the top here, I got a scan of a piece of pyrite. You can see just the geometry here. But this is 7.5 million triangles. Like this makes most computers choke. I mean, it's a lot of data. And the color maps are actually not particularly efficient either, but you get this really beautiful geometry. Whereas if I compare it to the wireframe I get off of the Z3D camera or that kind of depth camera, it's more soft and mushy.
Mm-hmm.
But that's when we started working with a company called Algorithmic on the displacement maps, because what they would be able to do is generate a normal map to add on top of it. So if you look at this, the base mesh normal map and diffuse, and this one here, and compare them, it's this geometry, but when it's rendered, it looks this way.
Wow.
So it goes from something like, I don't know, hundreds of megabytes, 7.6 million, yeah, to, 2 or 3 megabyte mesh file, and then like another 2 or 3 megabytes for these texture maps, and you get the same quality of rendering.
That's awesome. Hey, Josh, someone asked, what questions should you ask of a contract scanning firm to make sure that you have good color data? What other software do you use to get a 3D scan file using the HP camera?
Well, so the first part of that question I really like. So it would really depend on what you want to scan. So if you're scanning people, there's companies that really specialize in making a CG asset. So what I would want is to get the high quality wireframe or a point cloud and a processed mesh, something that's been turned into like almost like a CG or a game asset. I would want both of those things, because once I had both of those things, I have the ground truth geometry, and I also have the very good processed mesh. That's still quite expensive to do these days, but there are great firms doing it. But I would want both of those. As far as something that I was going to bring into CAD, so if it was more of like a consumer product, like everybody in 3D, it's always like a power drill or a mouse or something. In that case, I would probably want it depends what I wanted to do with it. I would definitely want the high quality point cloud and the corresponding color data. And then depending on what I was going to do with it, I might have to do some reverse engineering to get it into like a step or an IGES, kind of CAD format. The second piece of that question, Tito, was
what other software do you use to get a 3D scan file using the HP camera?
So the Z3D camera, I actually don't use the 3D scanning on it very much these days. There's for 3D scanning, I have a structured light 3D scanner that I use from HP, from a company we acquired called David. It's the HP. I use that. I also do a lot of photogrammetry these days. So again, it all comes down to what am I trying to scan. Depending on what I'm trying to scan, I use a very different tool set.
Okay.
This is just another example of another type of object that would scan. The Z3D camera was good at like kind of like non-symmetric, like kind of, it was really good at shoes. It was amazing at shoes, actually. If I had to scan a shoe, I might use the Z3D camera. That would be a good one.
Cool. That's the only question in so far.
All right. So this kind of brings us back to 3D printing a little bit, and this idea that I had from the PBR, the low quality geometry. So Pierre, if you can pull up video 5, let's take a look at that workflow. So Tito, this kind of goes to that gentleman's question. This is my workflow from about 2 years ago on how to texture a CAD part. So the first thing I did is I have to like turn it into a mesh, and then I have to bring it to ZBrush and unwrap it into UV space. So now it's like more like a 2D thing. Once I have the 3D and the 2D matched up, I can start adding those maps to it. So now it knows how to go on top. And this is Substance Painter. Amazing program. I love Substance Painter. So back to that question. about scanning and how I process scans for color, and Substance Painter is my main tool. Then I'd have to bring it into 3D Coat and displace the geometry and reproject the color back onto the geometry, and then get it into Rhino and get it ready for printing. So it was a pretty laborious task. But I'm gonna switch over to my hand cam right now and show you that the actual mouse that I'm using is that part. So this is printed on the, the MJF color printer, and I never finished it or anything, but just showing how you can go from, a CAD part to a textured part using the displacement map workflow. The really cool thing about what's changed between now and then is Substance added mesh displacement inside of Substance. Mm-hmm. So now and UV unwrapping. So now instead of having to use 5 or 6 different softwares to do that workflow, I can do that workflow with two pieces of software. So that's a really cool change that I've seen happen in the last 5 years.
That's awesome. That is so cool. Can you send me one of those?
Yeah, for sure. Yeah, for sure. I have another Logitech one that I'll send you. It's pretty cool too. All right. So going back over to the slide deck. This Pierre, if you can run, I'm going to queue it up a little bit, so don't hit play just yet. But if you can run mass customization for digital presses, this is when So in San Diego, we have a lot of the 2D printing capabilities in San Diego, and there are these huge machines that are incredible. So I started seeing like the soft proofing that was being done was all flat. And I got to know the guys, that company Algorithmic was acquired by Adobe. So I started working with the Adobe 3D and immersive team to say, hey, how can we do pre-visualization of packages or of printed items? Just how do we make that much easier for people? Because it's hard to visualize for most people things flat. So the way the 2D printing process works is you have a technical line that is called a die line. All the red lines, those are folds, and all the lines, those are cut lines. And those are hard to make. You have to be an engineer and know how to do structuring and know how to design this type of package. But once you have the die line, it's like that UV space that I showed you on the mouse. It's a 2D space that wraps around a 3D structure. So now you need that 3D structure. So if you have a 3D object like Adobe, they showed off some technology a couple years ago called Project Fantastic Fold, where you could take any die line and fold it digitally into a 3D shape. So with all of the UV space matching exactly where the 2D the 2D would be. So this is the way that digital that folding happens. It just folds it up like this. And the thing that was so cool about this now was I could take digital materials and apply them directly to the to the package. So if I take cardboard, add it to the cardboard, then you can use digital materials and put your inks on top of it. So this is kind of 3D visualization for 2D printing. So back to your original question about digital manufacturing, I really think of this as a type of digital manufacturing. Tito, I think you're muted if you're talking about.
Oh, sorry. I said that's awesome. But then I also said, someone asked, have you used the iPhone 12 Pro LiDAR camera in the process? To me, the LiDAR technology makes a lot of sense for creating excellent images that could be 3D printed.
So again, back to that company Prime Sense, like they got acquired way back when, and it's finally in a world-facing camera, and I'm so excited about it. I don't know, the geometry tends to be mushy, like I showed you from the scanner. So for 3D printing, depending on what you want to use, but I'm so excited that I think that this is going to really open up new applications that people haven't even thought of yet.
That's awesome.
Yeah. So switching back over to the so this is just an example of how the UV space is laid out onto the structure. And for Adobe Max, I partnered with some of the Z by HP ambassadors. Each one created a piece of artwork, and then each one was fit onto this template model that we had.
Mm-hmm.
So Pierre, if you skip forward to the next slide showing all the ambassadors' faces and their artwork. Yeah, this one, perfect. So yeah, we took all of this artwork and one more click should get that rotating. No? No. So this is a 3D model that's actually inside of PowerPoint. So PowerPoint started accepting 3D models about two years ago.
Yeah.
About 2 years ago. And I'm going to switch to my hand camera now and show you. So we did this really cool project where we made all of the boxes, and we 3D printed, or we printed on textile using our stitch printer the artwork on these bags. And then we 3D printed the sunglasses with digital textures on them. So if you see here, when you look at this, there's the paper has its kind of substrate material. The bag has these kind of lines in it, and the nylon has texture that we baked into it. So to me, this is really it was an amazing project to just kind of show off what's capable with HP's Capture Create experience. I mean, the most amazing thing, and this one I got to plug Jesse from GoProto, because he pulled off a miracle. We made 1,600 pairs of these things with custom boxes inside of I think it was like 2.5 weeks turnaround time. So yeah. There's nowhere else where that's really possible. That's so I love this project because it shows off everything.
Everything. Yeah. Wait, so tell me that file type, what is that file type that you're able to use a 3D rendering in PowerPoint?
Oh, that's called the GLTF.
GLTF, cool.
Yep, the GLTF. It's, again, I think it goes back to that iPhone. Like, how do you make 3D easier to use and more accessible? The GLTF PowerPoint, I think, is a step in that direction. Apple has their own file type that's like a cousin of the GLTF called the USDZ, I think. Mm-hmm. And it has animations baked in and textures baked in and all of that stuff there so that, people can just open it. And if you have a GLTF, like I do for that box with all of the textures on it, and I have the die lines and folds, I have a template that I can use in something like Photoshop or Illustrator, and I can change all the pixels and then print it and make it and visualize it in any way that I want.
That's awesome.
So, I see we're coming up against the clock, so I want to do fast through this last project.
Yep.
So this guy here my son was born shortly after all of that stuff, and I took paternity leave. So this my wife 3D printed this guy for us. And while I was on paternity leave, I needed a project. So I wanted to design a lamp. So I built this lamp out in a way that it could all fit inside of like a single MJF build, and it would snap together like an erector set. So you go from this piece to here, and then again, brought it back over to my friends at GoProto, and they printed it all out, and like a miracle, it all fit together the first time. But this took a lot of like thought about how I knew I wanted to do this kind of generative node and beam design that all snap together. And it's kind of where all the worlds come back together. So I went to the guys at Adobe, and they had this concept for a digital material scanner. There was a little bit of footage of it earlier. And they gave me a design, and like a rough design, like the shapes. And what it needed to do is it needed to light the object from different areas to create these digital materials. Perry, you can keep clicking forward there. Yeah, perfect. And I'm even going to go one more. I just wanted to remind people about the digital materials. And the way it does it is it takes a picture from the same angle of the same object with lighting from different sides. Mm-hmm. It's called stereophotometry. And then we added some polarization into it. So we had a polarizing filter to take the shininess away. And then from that, I can take that same piece of fabric and light it from all of these different angles, and even light it from behind and see how the light passes through. And we can generate those texture maps directly off of it. So how the Oliver lamp relates is I thought, I can use that same kind of node and beam structure to make this cone shape. So this is continued on to that, some renderings of it. And then, we started 3D printing on last summer. And the initial idea was we were going to wrap the whole thing in a textile. So, but nobody in our model shop knew how to cut and sew. So we have 3D printers. So what I decided to do was take a scan of the fabric and actually 3D print it into the material. So these are the displacement maps from the materials. So for stitches, you have this, and then for the fabric, you have that. I'm gonna switch over to my hand camera right now and show you what that looks like. But this to me was really like, tools for making tools. So if I zoom in here, I mean, you can just get a sense of the incredible detail.
That's crazy.
Yeah, it's unbelievable. And it all snaps and fits together. Like so. So the whole box itself was 3D printed using MJF and this displacement mapping technique. And if I cut back over to my slides and advance forward, I got a picture of the inside of the box. So that's what it looks like on the inside. Mm-hmm. And it lights it from all those different angles in the way that we showed you. And one of the things, Cito, and like, you've become one for me, and it's one of my favorite things about, creating and doing this type of stuff is it's always a team sport, right? Yeah. So like the guy on the right came up with the original concept. I did all of the 3D and geometry creation. Another guy was the kind of master behind the software. And this is half the team is from Adobe, half the team is from HP. And, this project got slowed down a little bit because of COVID, but we are, still cranking away. And we sent the devices to France, and those guys started integrating some software. So hopefully later this year, we'll have some cool news for the world about what we want to do with Project Cactus.
That's awesome. So after, you work on all these cool projects. Obviously, one has led to the next, like the lamp build out, leading that structure, leading to Project Cactus. So for a man like yourself, Josh, what is next?
I don't know. I've been,
what are you inspired by?
The problem is I'm excited by too much all the time, and like staying focused is the key. being at home nonstop, and having a 2.5-year-old now, time management becomes key. But that kind of studio of the future concept, we're still building it. So this past week over Thanksgiving, I started scanning my office behind me here, and let me go to choose. Yeah. So I started 3D scanning my office here, and my next plan is calling it Project Captive. And,
because you're captive, you're stuck there. I get it.
I'm gonna scan the whole space and create a virtual production studio. But we'll do another one of these chats about that when it's all finished. But the key, I hope, it's so fun to collaborate with you. Like to make tools for the community that's watching us today. It's really all of these ideas. One has just led to another, and it's all about like seeing what someone else is doing, collaborating with them, taking it a little bit further, adding your ideas to it, and just kind of seeing what's possible. We're still building the studio of the future, I guess.
That's awesome. That's awesome. Josh, thank you so much, man. Thanks for walking us down this journey. Do we have any last minute questions? Anybody have anything that they want to ask really quick? We could do like a rapid fire type thing. If not, just give it here for a sec. I'm just waiting for my person to let me know if there's anything coming through. But Josh, thank you so much, my man.
No,
Thanks for this talk. No, I really appreciate it. That was really fantastic.
Yeah, if anybody has any questions, you can find me on LinkedIn or get in touch with the company, and I'm happy to walk you guys through any of the stuff I showed today. It was a lot for a short period of time.
Yeah, Josh is fantastic. Any questions that I have, I go to him. He's a smart individual, knows lots of different things. So hit him up. Head of creators right there.
Thanks, everyone.
All right, everybody. Thank you so much. Have a good rest of your day.